This is the Hoover Dam, on the border of Nevada and Arizona, holding back the Colorado River. Hoover Dam was never designed to be safe, gentle, or reversible. It cost lives. It broke a river. It permanently altered ecosystems across the Southwest. But it also did something no other project could. It imposed control on a region defined by instability, and that control rewired the American desert into an economic system that could not exist before. Those who have seen Hoover Dam face to face often describe it as almost impossible at scale. Even people who have never visited recognize its reputation as something beyond normal infrastructure. With a height comparable to a 60-story building, it stood far above anything in the region. When completed in 1935, it ranked among the largest human-made structures in the United States. At the time, it was also the tallest dam on Earth. Its presence alone altered how Americans understood what the federal state could physically impose on a landscape. Built during the Great Depression on the Colorado River, the dam was never just concrete. It became a federal tool inserted into a hostile environment. Over time, it turned into a backbone of national infrastructure and a display of centralized capability. Its reservoir alone made it possible to irrigate roughly 2 million acres of land. That scale quietly changed what the American desert could economically support. Regions once limited by rainfall were suddenly integrated into national food production systems. Appearance alone never explained its importance. The dam functioned as force applied over decades. This system-level power is what reshaped the Southwest. In this video, we trace how Hoover Dam evolved into the most protected dam in America, because what it enabled could not be allowed to fail. Failure would not have been local. It would have cascaded across state economies. That protection began with the reason it was built: necessity. The construction of Hoover Dam began in 1931. Even before ground was broken, planners knew the project exceeded anything attempted before. Its size alone signaled that the federal government was testing the limits of engineering authority. What looks monumental today started as a response to instability. Floods, crop losses, and economic volatility created pressure for intervention at scale. Despite its later symbolism, the dam was born from crisis rather than ambition. At the start of the 20th century, farmers along the Colorado River tried to control water themselves. Man-made canals redirected flow toward nearby towns and fields. The system worked only until the river asserted its scale. Local solutions collapsed when faced with continental hydrology. In 1905, the Colorado River broke through those canals. Water surged uncontrollably into farmland. Flooding destroyed thousands of acres of productive agricultural land. The damage exposed how fragile regional growth really was. Entire harvest cycles were erased in a single season. For the next 2 decades, Congress spent more than $10 million seeking solutions. The goal was simple: protect Imperial Valley farmers from repeated floods. Responsibility shifted toward federal agencies capable of acting at scale. This marked the beginning of centralized river control. Water management became a national political issue rather than a local concern. As studies expanded, the U.S. Bureau of Reclamation focused on the Colorado River itself. Engineers first experimented with smaller dams on tributaries. Results showed that partial control was insufficient. A single large structure became the preferred solution. Only mass could counter mass. That conclusion changed the mission entirely. A larger dam could regulate floods and deliver irrigation water simultaneously. It could stabilize agriculture across state lines, and it could impose predictability on a volatile river. Predictability was the real economic breakthrough. From that logic came an additional consequence. The dam would not only control water, it would generate hydroelectric power at national scale. Homes, factories, and businesses would all become tied to it. Energy security and water security merged into one system. Such scale demanded labor the region did not have. To build the dam, the government fabricated an entire city in Nevada. Boulder City was created to house more than 5,000 workers. Infrastructure followed labor, not the other way around. This reversal reflected emergency-era federal planning. Boulder City became a magnet for unemployed men during the Depression. Thousands arrived hoping for stable work. On peak days, more than 3,500 workers labored simultaneously. The project absorbed national economic pressure directly. Wages from the site circulated back into struggling communities nationwide. Across 4 years, roughly 21,000 men participated in construction. The work was dangerous and relentless. Deaths occurred on site, a human cost absorbed into progress. The economic engine was built with real lives. Official records understated risk, but workers experienced it daily. Boulder City itself reflected federal control. It sat on federally owned land. There were no elected officials. Administration came directly from the Bureau of Reclamation. Civil authority was temporarily suspended in favor of efficiency. Only decades later was Boulder City formally incorporated in 1960. By then, its existence was already a byproduct of infrastructure power. The dam had reshaped governance as well as geography. Scale altered everything around it. Even democratic processes adapted to construction logic. That scale required precise dimensions. The dam's height was engineered to reach 726.4 feet. This was necessary to resist the pressure of the Colorado River. At its base, the structure measured 660 feet thick. At the top, it narrowed to just 45 feet. Every dimension was calculated against failure scenarios. Behind it, the reservoir grew beyond precedent. For decades, it remained the largest artificial lake in the world. It is still the largest in the United States today. Its weight alone altered geological reality. Few projects had ever changed the ground itself. The mass of stored water deformed Earth's crust. More than 600 small earthquakes were recorded in the late 1980s. This consequence was unplanned but measurable. Control came with systemic side effects. Engineering success produced geological feedback. Oversight of this operation fell to engineer Frank Crowe. He was given 7 years to complete the project. Delays triggered financial penalties of roughly $3,000 per day. Time itself became a pressure system. Speed became inseparable from survival. Crowe earned the nickname Hurry Up Crowe. The pace never slowed. Schedule and budget dictated every decision. Human limits were pushed to meet national deadlines. Efficiency overruled comfort at every stage. To begin construction, the river had to be moved. 4 diversion tunnels were driven through canyon walls. 2 cut through Nevada, 2 through Arizona. Each had to withstand the river's force. The river was treated as an obstacle, not a partner. Initial drilling relied on manual methods. Each hole was drilled individually and packed with dynamite. The process consumed time the project could not spare. Efficiency became survival. Delays translated directly into financial and political risk. A new system replaced it. 10-ton drilling trucks were introduced. Each carried 50 men and operated dozens of drills simultaneously. Industrial scale replaced human pace. Mechanization compressed time itself. 8 trucks and 500 drills transformed progress. Entire tunnel walls were drilled at once. The work finished ahead of schedule. Speed redefined feasibility. Federal confidence in megaprojects hardened here. That success made the next phase possible, the power plant. Construction shifted toward the dam's power infrastructure. 4 intake towers were erected. Concrete buckets crossed the canyon via cableways. Each block had to cure under controlled conditions. Errors at this stage would have been irreversible. Workers sprayed drying concrete to prevent cracking. Inside the structure, 600 miles of cooling pipes were embedded. Water circulated continuously to manage heat. The dam functioned like a living system. Thermal control determined long-term stability. On September 30th, 1935, the project was formally commemorated. President Herbert Hoover marked its completion. The structure now existed as national fact, but its identity remained contested. Politics lingered in its shadow. That dispute centered on its name. Before construction, it was called the Boulder Canyon Project. Original plans placed it in Boulder Canyon. Later, the site shifted to Black Canyon. The name never fully followed. Public memory lagged behind engineering reality. Boulder Dam persisted informally. Then, Interior Secretary Ray Lyman Wilbur renamed it after Hoover. The decision triggered public backlash. Many blamed Hoover for the Depression. Infrastructure could not erase political anger. Despite official naming, locals and reporters resisted. Boulder Dam remained common language. Political resentment lingered. Infrastructure did not erase public memory. Names reflected trust as much as authority. Congressional documents, however, used the official name. Federal authority prevailed in records. The dam's identity became dual. Power does not require consensus, it only requires enforcement. What followed was not just protection, it was dependence. By the 1940s, entire regional systems were already locked into Hoover Dam's output. Agriculture schedules, power grids, and municipal expansion plans were designed around its guaranteed flow. Water allocations were no longer negotiated annually. They were assumed. Cities expanded outward because the dam made expansion predictable. Power contracts were written decades ahead. Farmland value rose not because rainfall improved, but because water delivery became stable. This created a structural shift. Hoover Dam stopped functioning as infrastructure and began functioning as an assumption. Once growth is built on an assumption, failure is no longer tolerable. There was no backup system capable of replacing its output. No alternative river control could absorb the load. At that point, the dam didn't need to be defended symbolically. It had to be defended because too much depended on it. The Southwest reorganized itself around one controlled system. Agriculture scaled beyond natural limits. Cities expanded into climates that would otherwise restrict them. Industry planned around uninterrupted power. Hoover Dam became a single point of continuity, not because it was flawless, but because the region was no longer designed to function without it. That posture never fully disappeared. Today, Hoover Dam functions like a city. It has its own police force. Specialized security systems monitor every sector. Protection is permanent. Threat assumptions never fully relaxed. Contract security staffs, vehicle checkpoints. Both Nevada and Arizona entrances are controlled. After September 11th, access restrictions increased further. Casual visits now pass through multiple barriers. Visibility masks vulnerability. This raises a simple question. Why is Hoover Dam so protected? The answer lies in dependency. The system cannot fail. Failure would cascade outward. The dam created the largest reservoir in the country. It covers about 248 square miles. It holds roughly 28.9 million acre-feet of water. Scale equals leverage. Control concentrates power. That water feeds farms, cities, and industries. California, Nevada, Arizona, and Mexico depend on it. Irrigation, flood control, and power remain intertwined. The desert economy runs through the dam. Alternatives remain limited. 17 turbines generate electricity for 1.3 million homes. Energy output underpins regional growth. Without it, cities would contract. Reliance is structural. Modern life assumes continuity. For time, the dam was reframed as heritage. Designation and tourism followed. Not because the risk disappeared, but because dependence had already normalized it. Yet its legacy is not neutral. It disrupted a river permanently. It damaged ecosystems downstream. Its success created irreversible dependence. Control replaced resilience. The American Southwest grew because the dam worked. That growth now assumes its continued operation. Economic power rests on engineered stability. Once the Southwest reorganized itself around Hoover Dam's output, failure stopped being an option. The region no longer had a fallback system capable of absorbing disruption. Water, power, agriculture, and urban growth now assumed continuity. At that point, protection wasn't a policy choice. It was a structural consequence of dependency. The gamble became obligation. Hoover Dam did not simply control water, it converted volatility into permanence. The American Southwest did not grow because the dam was perfect. It grew because the system it enabled became unavoidable. Cities expanded, agriculture scaled, energy centralized. The gamble succeeded, and success removed the option to walk away. Hoover Dam turned desert into an economic engine and bound an entire region to a single piece of infrastructure.